This is the NEET 2018 question on de Broglie concept. The problem says an electron of mass m moving with a velocity v equal to v naught I cap, who is greater than 0, enters an electric field minus E naught I. E naught is also greater than t equal to 0. Lambda naught is its de Broglie wavelength initially, then its de Broglie wavelength after some time is how much? Well, first let's write lambda naught. Lambda equal to h by p or h by mv. When velocity is v naught, respective wavelength is lambda naught. That is given for us. Now what he is saying is, after some time t, some time t, see the electron is given that, it is given that v equal to v naught I cap, that means it's moving along positive x-axis with a velocity v naught. But electric field is minus E naught I cap. The electric field is applied like this, minus E naught I cap. See, the first thing that you need to understand is a positive charge moves along the direction of applied electric field. Negative charge moves against the direction of field. Being electron is a negative charge, when the electric field is applied like this, electron moves continuously in the same direction because it's a negative charge. Negative charge moves against the direction of the field. So this is being a negative charge, it moves against the direction of the field. So after some time t, V can be calculated as U plus EAT. So what is that A we can calculate? The electric force applied is EQ, that is E, which can be causing a force, mass into acceleration. That implies acceleration is E into E by M. This E could be called as E naught because it was given it as E naught. So V will become U. U is initial velocity. Initial velocity is given as V naught plus A. This is the velocity that it has got after some time. Now its new wavelength, lambda equal to h by mv. H by m, in the place of v after some time we can write an equation, v naught plus e naught e by m and t. So what I can do is, I have to express it in terms of lambda naught. Lambda naught is h by mv naught, as we have explained. This implies, what we can say is h equal to lambda naught mv naught. So to simplify the expression, in the place of this h, we will write the value from lambda naught. That implies what happens, lambda equal to, in the place of h, lambda naught mv naught by m of whatever may be the equation, v naught plus eq by m of t. M can be cancelled. Now lambda naught v naught, let us take the v naught common here because the answers are in that format, 1 plus eq. There is no v naught here, so I have multiplied and divided, and multiplied one value is outside, divided value has to be available here. This is the equation. Now v naught and v naught also can be cancelled. So new wavelength is original wavelength by 1 plus uq by mv naught of t. That's the answer for the problem. Lambda naught of, oh no, not this one, divided, because it is divided by this one, lambda naught by 1 plus eq by mv naught of t. That's how we solve that problem conceptually. After solving that problem, there is another problem which says the de Broglie wavelength of a neutron in thermal equilibrium with heavy water temperature T and mass m is how much? We can write de Broglie wavelength as lambda equal to h by p, that is mv. But we know momentum equal to, as momentum equal to mv, we can express kinetic energy as p square by 2m. So p can be expressed as 2m times of kinetic energy or energy. So I can rewrite my equation as lambda equal to h by, in the place of momentum, 2m times of kinetic energy. Now, because it's a neutron in thermal equilibrium moving with a certain temperature, it will have a kinetic energy that is equal to 3 by 2 times of Boltzmann constant into absolute temperature. So in the place of this energy, I can substitute this relation. That implies lambda becomes h by root of 2m. The place of kinetic energy, 3 by 2 Boltzmann constant into temperature. These two can cancel. So lambda equal to root of h by 3m kt. That's the equation, right? That's how we get to that answer. So this is based on kinetic energy of a particle with a certain heat energy, certain temperature is 3 by 2 times of kinetic Boltzmann constant into absolute temperature. Now this is based on the kind of law of equipartition, that each degree of freedom will have certain energy, certain kinetic energy. That's how we solve this problem. Thank you for watching.